Welcome to our video number 2 for Applied Regression Analysis. I'm Mark Ledbetter, and in this video we're going to review some basic statistics. This is part 1 of that review. Now, what we're going to talk about are the types of studies and some basic vocabulary. We're going to go over the data types, levels of measurement. These are things from our introductory statistics course. Then we're going to go over some confounding and nuisance variables, remind you about the difference between parameter and statistic, and then we'll get started on some descriptive statistics. So there are two basic types of studies in statistics. There's an observational study, where we just simply observe the outcome. We don't do anything to influence that outcome or modify it. Okay? So we're objective observers. We collect it and then we analyze it. And those are observational studies, and that's what we'll be dealing with this semester. And then you have experimental design, where you do control the input variables and the conditions. And if it's done correctly, you can end up with a determination of cause and effect. Okay. Now let's talk about some vocabulary for data. An individual is the people or the objects that are included in a study. We can also call them subjects if they're people or animals. So if they're alive, they can be subjects. If they're not alive, we would call them individuals. So like trees or plants or what have you. And then we have variable, and it's something that we want to measure or observe, and it changes value, right? It's variable, it changes. Population data, this is data from a census. That's where you collect the information from every person in that population. And that's very difficult to do in most cases. And then we have sample data, and that's data taken from a subset of the population, just some of the individuals in that population of interest. And it needs to be done in a representative way if we want to be able to make inference with it. And then we have a random sample, and it's sometimes confusing for students, the difference between random sample and simple random sample. In a random sample, every member of the population has the same chance of being selected as any other. In a simple random sample, it doesn't seem as simple to me, but okay, I didn't name it. If I have some group of size n, let's say, it could be 10 or 20 or 30 or 50 or 100, I have every group, every possible subset of size n has the exact same chance of being selected. So if we say a sample size of 30, a simple random sample would say that any possible group of 30 within the whole population has exactly the same chance of being selected. That's a simple random sample. Now we have qualitative and quantitative data types. Qualitative is another name for that is categorical data. Everything is just a label or a category. We can have numbers, but they don't act like numbers. We can't add them or subtract them or multiply or divide them. They're simply labels or placeholders like phone numbers or zip codes. And then quantitative, those values really can be interpreted as numbers. In other words, we can add, subtract, multiply, divide, etc. If data is quantitative, it can either be discrete or continuous. It can't be both, but discrete or continuous. So discrete is something that we can count. It may be infinite, but we can count it. The integers can be counted, but they're infinite. I can start in the positive integers, I can go 1, 2, 3, and I can keep on counting them. In the negative integers, I can count them. -1, -2, -3. I can keep on going. They're infinite, but I can count them. Okay? And then there's finite, which is more likely to be the case for discrete, but not always. Okay? And then we have continuous. There are no gaps between the values, and so for any range of values, there is an uncountably infinite number of values. So if I take between 0 and 1, there's a famous proof that says you can't count the values between 0 and 1. I can give you an easy reason for that, and that is that you just keep adding decimal places, and you can keep on adding them, and there's no way to assign those to a one-to-one because you keep changing the number of decimal places. Now there's a much more formal and intuitive proof, but we won't go into that. So the levels of measurement from lowest to highest, nominal is where we just can only, we use this on qualitative data and we can only categorize it. We can't do anything else. Ordinal data, we can put it into categories, but we can also rank it. We can put it into order. So examples would be ranks. If I come in first place in the race, you don't know how much further ahead I was than the second person. You just know that I came in first. And interval data, that would be like the, say, degrees Fahrenheit. We can take the difference between the values, and that's meaningful. And we can definitely put them in order. So 100 degrees Fahrenheit is definitely higher or hotter than 90 or 99. Okay. And the difference between the degrees is meaningful. 70 degrees minus 40 degrees is 30 degrees. But the ratios are not. Ratios are meaningless in Fahrenheit. And there's a reason for that. It's because 0 degrees Fahrenheit is not the absence of temperature or heat. And so if the 0 is not a natural 0, then the data is only interval data, not ratio. And so ratio data, the highest level of measurement, has a natural 0. People get confused by this. If I say the heights of men, then or the heights of women, either one, if I say that and I say, is this ratio or interval, people overthink it and say it's interval because 0 height means you don't have a person. Exactly, it's the absence of height. So it's a natural 0, so it's ratio data. And if I'm 6 feet tall, I'm definitely twice as tall as someone who's 3 feet tall, right? Okay. So when we ask, always provide the highest level of measurement. Now a confounding variable, it's a variable you're not interested in, but it may affect the outcome variable or dependent variable or result or response. And we can deal with these by controlling them, or we can randomize over their possible values. We'll talk more about that later in the course. A nuisance variable is a variable that does not normally vary much across the levels or conditions of, say, an X value, an independent or predictor value. But if it does vary, that may, this word is supposed to be may, increase the experimental error. And we can deal with this with a technique called blocking. And I don't want to get into it in this video, but when we get to that section, you'll see what blocking is. It's a randomization over the possible values here. Okay, and we'll control it. So a characteristic, this is something about a population or a sample, and it can be either one. So a mean or average, standard deviation, range, anything you want to think about as a measurement, that's a characteristic, and there's always two of them. There's the parameter, which is the true value for the whole population, and there's a statistic, which is the value of the sample that you've taken. And we use the statistic to make an inference about or estimate the parameter. Okay, so population, parameter, sample, statistic. Match up the letters, the first letters, and you'll have it right. Now let's talk about descriptive statistics. The first is the sample mean. You add up all the values and divide by how many you have. The notation here, this is the summation sign. I equals 1, so we go from 1 to n. And we integrate, and we do this by 1. So these are whole numbers. We go 1, 2, 3, up to whatever n is. And so x sub 1, x sub 2, those are just the individual values from our sample in this case. And n is the total number of values that we've taken in our sample. Then we have a sample variance. And the sample variance has this lovely calculation. Now these two equations are exactly the same. This is the sum of all of the differences of the values from their mean squared. So we take each value, subtract its mean, x bar, that difference we squared. So all these numbers on the numerator, they're all positive. And we add them up. And then we divide by n minus 1. And there's a lot of reasons for doing that. I'm not going to get into it here. That's another course. And we can rearrange this and rewrite it using this. And this is the calculation formula. We sometimes call it the shortcut formula, but it doesn't seem like a shortcut. We sum up the squares of each of the numbers, and we add up all the numbers and take that square. We can subtract these. This top number is always positive. And by doing this, don't forget your n over here, n times this, divide by n minus 1, it's exactly the same equation. And we don't have to deal with these messy differences. The sample standard deviation is simply the square root of the variance. Quartiles. Quartiles are quarters. So Q1 is the first quarter, or 25th percentile. So a percentile is, in this case, 25th percentile means 25% of the data is below the value. 50th percentile is the median, and 50% of the data is below that value. 75th percentile is the third quartile, and 75% are below that value. Then we have box plots. And in the box plot, this first, and they can be horizontal or vertical, this first value here is the minimum. This value on the box is Q1, the red line, Q2, this side of the box, Q3, and this is the maximum. And of course, this would be the max, Q3, Q2, Q1, and the minimum here. And depending on, we can determine skewness here. This one looks fairly symmetrical to me. The line in the middle is, the red line, is near the middle of the box. And this one looks fairly symmetrical, but I might say that this red line is slightly closer to this blue line. So the bigger side of the box is the side where we have the skewness. Okay? So, and that's my cat you hear whining a little bit. All right, so that's a review of the descriptive statistics. That's enough for this video. Please don't forget to put in your lecture notes to Google Drive by midnight on the due date for this video. Be neat, again, for you. If you need any of these formulas from today's video, please put them on your formula sheet. If you have questions, come see me virtually in my office hours or email me. So see you next time, and be safe.